Hello, distinguished viewers all over the world. Welcome to Simplified Maths once again. I am your host, Mr. Mike Omeni. And please, if you have not subscribed to our channel, Simplified Maths Class, please kindly do that by clicking the red subscribe. God bless you as you do that. All right, so today our topic is probability of balls. Probability of balls. We are going to be taking the probability of balls one pick, and then we'll take probability of balls two pick with or without replacement. All right, so we have a question on the board here. A bag contains 9 balls, all identical in shape and size except color. If 2 of the balls are white, 3 are red, and 4 are green in color, and a ball is picked at random from the bag, what is the experimental probability that the picked ball is I, red, I, not green, I, red or green? All right, let's see how we can do this, and then IV, black. Solution. So the bag contains 2 white balls. 2 of the balls are white, and then we have 3 are red, 3 red, and then we have 4 green balls. All together we have how many balls? 2, 3, 5 plus 4, 9 balls. All these 9 balls are identical in shape and size except the color. And now these balls are put in a bag, and you want to pick out a ball from the bag without looking at the bag. That is at random. You want to randomly pick a ball from the bag. So let's see, what is the probability that the ball you pick, the probability that the ball you picked is a red ball. Probability of picking a red ball. So we're going to have, how many red balls do we have in that bag? There are 3 red balls. So that will be 3 over how many total balls we have in the bag, which is 9. Remember that the probability of an event is equals to the number of required outcomes divided by the number of total outcomes. So the required outcomes is the red ball, which is 3. And then the total outcomes is the total number of balls, which is 9. All right, so we reduce the fraction to the lowest term. 3 here, 1, and then 3 into 9, 3 times. So it means the probability of picking a red ball is 1 over 3. So what is the experimental probability that the ball you pick is not green? Not green. All right, so not in probability means 1 minus. Not is 1 minus. Then green. How many green balls do we have? 4 green balls. All over the total number of balls, which is 9. Okay? So we have 1 minus 4 over 9. 1 minus 4 over 9 is certainly 5 over 9. 5 over 9. All right? So how do I have to resolve that? 1 minus 4 over 9. It simply means just take 9 minus 4. That gives you 5 over 9. That's all. Or you can simply use your LCM. 1 over 1 minus 4 over 9. 1 over 1 minus 4 over 9. The LCM is 9. 1 into 9 is 9. 9 times 1 is 9. 9 into 9, 1. 1 times 4 is 4. 9 minus 4 will give us 5 over 9. So 1 minus 4 over 9 is certainly 5 all over 9. Please take note of that. All right, so we are done with that. The next one, I. They say, what is the probability that the ball is red or green? The probability that it is red or green will be equals to red. What's the probability that the ball you pick is red? How many red balls do we have? 3 over 9, the total. Or means plus. What's the probability that it is green? How many green balls do we have? 4 over 9. So 3 over 9, I've told you or in probability means plus. All right, so 3 over 9 plus 4 over 9 simply means 3 plus 4, and that will be 7 over 9. And you can't reduce that to any other lowest term. That's your answer. And finally, number 4. What is the probability that the ball you pick is black? All right, we were told that the bag contains 2 white, 3 red, and 4 green balls. There's no black ball. So the probability of picking a black ball is 0 because there is no black ball in that bag. So no matter the number of times you dip your hand into the bag to pick any ball at random, you will never see a black ball in the bag. So the probability of picking a black ball equals to 0 because there is no black ball in the bag. All right, so that's the probability of balls 1 pick. Now we're going to go into the probability of balls 2 pick with or without replacement. Without waste of time, let us see how we can take 2 picks. That means in the first instance, you picked 2 balls at the same time from the bag. When you pick 2 balls at the same time in the bag, that is 2 pick. Or you pick 1 ball, and after picking 1 ball, you now pick a second ball. You pick 1 and then pick a second one. It means you're still talking about 2 picks. So it can come in any of those 2 formats. All right, so anytime you're dealing with the probability of 2 balls, picking 2 balls from a bag, understand that you can either pick the 2 balls one after the other, all right, or you pick the 2 balls at the same time. All right, so let's take a problem on that. A bag contains 3 red, 4 black, and 5 white balls, all identical in shape and size. All identical in shape and size except color. A ball is picked and a second ball also picked. The second ball also picked at random from the bag. At random from the bag. Okay. What is the probability? What is the probability that the ball that they are okay, let me say, what is the probability that the first is red and the second is black? One is red and the other black. They are of same color. All right, so here we assume first with replacement. Assuming the balls are picked with replacement. All right, so want to solve this on the board. They said a bag contains 3 red, 4 black, and 5 white balls, all identical in shape and size except color. A ball is picked and a second ball also picked at random from the bag. What is the probability that the first is red and the second is black? What is the probability that one is red and the other black? And then what is the probability that they are of the same color? So we want to take this. But they said we should assume with replacement, which means when you pick the first ball, you replace it and then pick a second ball. So we want to handle with replacement. All right, solution. Now understand that in this bag, there are 3, 4, and 5 different colors of balls that gives us a total of 12. So let's pick them out. So we have 3 red, solution. So we have 3 red, then we have 4 black, and then 5 white balls. And so the total is 3 plus 4, 7 plus 5, and that's 12 balls. There are 12 balls in that bag. We want to pick them one after the other with replacement. So the probability that the first is red and the second is black in that order. So we are looking for the probability of red and black. Meaning the first ball you pick is red and then the second ball you pick is black. But make sure that after picking the first ball, you replace before you pick the second one. All right, so the probability of picking the first ball to be red. Remember that there were 3 red balls all over the total of 12. So you're going to have 3 all over 12. Where at the point where you pick the first ball to be red, there were 3 red balls all over the total balls of 12. So that's 3 over 12. So the probability of picking the first is red, and in probability means with times. Now the second being black, we replace back the red ball. All right, so which means we still have 3 red balls intact, and we still have a total number of 12 balls intact by replacing after the first pick. Okay, so we want to pick the second one, and as we pick the second one, it is a black ball. In that bag there are 4 black balls, so that will be 4 all over. The total number of balls is also 12. So when we pick the first one to be red, there were 3 red balls over 12 total balls. We picked the second one to be black, and there were 4 black balls all over 12. Remember that we are replacing. When you replace, it is unaffected by the color of the ball you have picked, and it is also unaffected by the total number of balls. They are intact because you replace them. All right, so, and in probability, the first is red and the second is red, meaning that we should multiply. All right, so 3 times 4 will give us 12. All over 12 times 12 will give us 144. All right, so we reduce to the lowest term. 12 here, that's 1. 12 here, and that's 12. All right, so we have 1 over 12. 1 over 12. 1 over 12. Okay, that's correct. So 3 times 4 will give us 12. All over 12 times 12 is 144. So 12 into 144 will give us 1 all over 12. So that's our answer. Please take note of that. Okay, so let's try the second one. Let's create space here to try the second one with replacement. All right, so in the second instance, they said, what is the probability, what is the probability that one is red and the other black? One is red and the other black. So it means we are dealing with the probability that one is red and the other black. One is red and the other black. We are simply trying to say that when we pick, it's either we are going to have red, black, or we are going to have black, red in that order. Because they said one is red and the other black, meaning that the first one we pick is red and the second is black. Or probably the first one we picked was black and the second is red in that order. So when you hear one is red and the other black, it means you have red coming before black or black coming before red. So the order doesn't matter. Unlike the first one, they gave you the order. But here the order doesn't matter. They didn't give you. So it means you either have red, black or black, red. All right, so we are going to do that. So this will be the probability of, if the first is red, how many red do we have? So 3 over 12. 3 red out of 12. And the second is black. How many blacks do we have? We have 4 blacks out of 12. Remember, we are replacing, so it doesn't affect the balls. Or in probability, meaning plus. All right, so maybe the first is this time around black. So the first we pick is black. That'll be 4 over 12. 4 blacks over 12. And the second is red. The second one is red. How many reds? 3 all over 12. Please take note of that. So we have the first being red, the second black. Or plus the first being black and the second red. That's what we are trying to do. So we are going to have 3 times 4, that will be 12. All over 12 times 12 is 144. Or meaning plus 4 times 3 is 12. all over 144. So we are going to have 12 plus 12 is 24 all over 144. So we are going to reduce that to the lowest term. We want to reduce that to the lowest term. So how do we reduce to the lowest term? So our answer here is 24 over 144. Okay, so first and foremost, let's divide by 12. If we divide here by 12, you have 2. And you divide here by 12, you have 12. All right, so we'll divide 2 here, 1. 2 here, 6. So your answer is 1 over 6. That's our answer. So the probability that one is red and the other black will simply give us 1 all over 6. And now the last one, they say probability that they are of same color. Probability that they are of same color. Of same color. I. So we want to look at of the same color. Probability that they are of same color. All right, so if we are talking about of same color, okay, of same color, let's not forget we had 3 red, I think 4 blacks, and then we had 5 white balls. Altogether 12 balls. Okay, let's not forget that. All right, so of same color, meaning that the probability that the first one you pick is red and the second red, or the first one you pick is black and the second black, or the first one you pick is white and the second white. All right, so that's what we mean by of the same color, meaning that the first one we pick is a red ball and the second is red, or probably the first we pick is black and the second is black, or the first one we picked is white and the second white, meaning that they are of same color. It's a must that the 2 balls you pick will be of the same color. And being of the same color means they can either be red red or black black or white white. Let's not forget that. So we are going to resolve for that. Okay, so the probability of red and red. So this is going to give us the first one being red. There are 3 red balls over 12. And the second one being red. There are 3 red balls over 12. We are through with that. Or meaning plus. Okay, the first one being black, there are 4 blacks over 12, and the second one being black, there are also 4 blacks all over 12. Okay, or it means we add. And then the final one, the first one being white, there are 5 white balls over 12, and the second one being white, there are also 5 white balls over 12. Why? Because we are replacing the picked balls back. So when we replace, the second pick is unaffected by the ball you have picked out because you have returned it back. All right, so we are going to have 3 times 3 will be 9 all over 144. That's 12 times 12. Plus 4 times 4, 16 all over 12, 12, 144. Or meaning plus 5 times 5, 25 all over 144. All right, so if we add all this, 9 plus 16 plus 25, 9 plus 16 plus 25, that will give us 50. So we are going to have 50 over 144. So we reduce this to the lowest term. 2 here, 25, and 2 into 144, that's 72. 144 by 2. All right. So that's our final answer. We cannot reduce this fraction again to the lowest term. And remember, in probability, you must always reduce your fractions to the lowest term. And I've told you that a probability of fractions will always be normal fractions, all right? Proper fractions. You will never have an improper fraction as an answer in probability. It will always be proper fractions. All right, why? Because proper fractions are fractions that range between 0 and 1. All right, they are in between 0 and 1. They are not less than 0. They are not greater than 1. Take note of that. All right, so we've been able to do the probability of balls, 2 picks. All right, 2 balls are picked with replacement. And that's what you have when you're dealing with replacement. All right, so let's take the final example when we have without replacement. 2 balls without replacement. You're picking 2 balls, but this time around without replacement. Let's see how when you don't replace, what happens when you don't replace. So we have without. Without replacement, 2 picks or 2 balls are picked. Okay, So that's the final one. We want to take 2 picks this time around with replacement. When you pick 2 balls, one after the other with replacement, what happens? Let's quickly take that. All right, so we have a question. Let's say a ball contains a bag or a box. A box contains, let's say, 4 blue balls and let's say 6 white balls, all identical in shape and size except color. If a ball is picked at random and without replacements, a second ball is picked. What is the probability that one is blue? One is blue. We have how many balls? Okay, one is blue and the other is white. And they are of different colors. All right, so let's just try this without replacement before we close the slide. We want to see what happens when you are picking one ball and then picking a second one without replacement. Let's see how without replacement alters the entire program. All right, solution. So here the bag contains 4 blue. There are simply 4 blue balls and then we have 6 white balls. So the total number of balls in that box is 10 balls. Now, they say we want to pick 2 balls, one after the other, without replacement. What is the probability that one is blue and the other is white? So the probability that one is blue and the other is white. Okay, so one is blue and the other white, meaning that you are having the probability of blue coming first before white, or the probability that white comes first before blue. That's what we mean. All right? The probability that blue comes first before white, or the probability that white comes first before blue. Please take note of that. All right. So we are going to have, let's take blue before white. When we pick the first ball, what is the probability that it is blue? So that's 4 over 10. 4 over 10, that's the first instance. And after picking that first ball, which is blue, you did not replace. You kept it outside. You didn't replace. You now want to pick the second ball and it is white. So, and picking the second ball to be white, there are 6 white balls. But the total number of balls will be affected. There will no more be 10, but 9. Why? Because you have picked out the first ball to be blue and you did not replace. So at the instance where you picked the first ball to be blue, there were 4 blue balls, all over total number of balls being 10. You kept the blue ball out. You didn't replace it back. And you now picked, your second pick is white, so you have 6 white balls. But the total 9 is affected because 1 ball was outside. So that gives us a total of 9. All right, so we want to multiply this. Or, meaning plus, we add. We are starting again. We want to start. What about if, when I pick the first ball, it is white? At the time when I'm picking the first ball, if it is white, it means we're having 6 white balls all over 10 total balls. And we now want to pick the next ball, and the next ball this time around is black. Remember that, or blue, sorry. Remember that when I picked the white ball, there were 6 white balls all over the total of 10. In the second pick, I kept that one out. I didn't replace. I want to pick blue balls now. How many blue balls do you have? 4 in the bag. But the total number of balls becomes 9, no more 10, because we did not replace. So it will either be that we are going to have 4 over 10 times 6 over 9, or 6 over 10 times 4 over 9. So each time you're picking the second ball, you don't replace, you keep it out. So the total number of balls is affected. And that particular color you picked without replacement is also affected by the number of balls in the bag. So we are going to have 4 times 6. That's 24 all over 10 times 9, which is 90. Or plus 6 times 4. 24 all over the total 10 times 9, which is 90. So 24 plus 24 will give us 48 all over 90. So we reduce it to the lowest term. 2 here, 24. 2 here, 45. And I'm sure nothing will divide that again. It therefore means that the probability that one is blue and the other is white will give us the proper fraction 24 all over 45. That is the probability. Okay? Now, understand that if you're looking for the probability that they are of different colors, it means we'll still be doing the same thing. Different colors meaning that we are having black, white, or white, black. All right, so it will still be the same thing. Please take note. I purposely wrote it out so that you understand. So if you're saying what's the probability that they are of different colors, meaning that the first you pick will be blue, the second white, or the first you pick will be white, the second blue. They are maintaining different colors. But assuming we are asked to find of same colors, they are of same colors, what happens? I think that's the one I have to show you, because what we just did here means they are of different colors. One is blue and the other white, meaning that they are of different colors. All right, so let's try of same colors. Of same colors. Assuming we are picking them of same colors. Now understand that it is only when we are picking the second pick, when we are trying to pick the second ball, that it is affected by whatever we have to do. All right, so I probability of same color. So if we are dealing with of same color, it means we are trying to talk about the probability of the first being blue, the second being blue, or the probability that the first is white and the second is white. They are of same color. All right, now when we pick the first ball, if it is blue, remember that there are 4 blue balls all over a total of 10 balls in that bag. We didn't replace, and we dipped our hand and we still pick another blue. This time around, it means that there are 3 blue balls and the total balls 9. Take note of that. I'll repeat. When we pick the first ball, if it is blue, there are 4 blue balls over a total of 10. That's why you have 4 over 10. But you did not replace the blue ball. You kept it outside without replacement. You now dipped your hand and you picked another blue ball. It means you are now picking from 3 blue balls, because there were 4 before, but you kept one outside. You didn't replace. So 3 blue balls, the total now becomes 9. Take note of that. So, or maybe we are starting again. But this time around, we pick the first ball. It is white. How many white balls do we have? 6 out of 10. And you dipped your hand without replacement. You kept the white ball. You dipped your hand. You picked another white balls. How many white balls do we have left in that bag? Only 5. And the total number of balls being 9, because you did not replace. All right. So we're going to have 4 times 3. That will be 12 all over 90, plus 6 times 5. That will be 30 all over 90. All right. So this will be 30 plus 12. That will be 42 all over 90. So it means that the probability that they are of same color will be equal to, we reduce to the lowest term. 2 here, that's 21 all over 2 here, that's 45. It means we can still divide 21 by 3. 21 by 3, that's 7. So we have 7. So this will be 7, and 45 by 3. 45 divided by 3, that's 15. So we can still reduce to the lowest term. It means that our final answer will be 7 over 15. Please take note of that. 12 over 90 plus 30 over 90 will give us 42 over 90. So 2 into 42, that's 21. 2 into 90, that's 45. 3 into 21, that's 7. 3 into 45, that's 15. It therefore means that the probability that the two balls picked are of same color will be 7 over 15. Take note of that. So you can see that when we are dealing with replacement, the total number of balls are unaffected, and even the ball you have picked out in the first instance will still be returned, and so the colors are unaffected. But we should be careful when you're dealing with without replacement, because anytime you pick the first ball, you are not replacing before you pick the second ball. It's very important. So please take time to study this with or without replacement, because most times you write exams, you will definitely meet with or without replacement in your exams. Thank you very much for attending our slide, probability of balls. If you have not subscribed to our channel, please do click the red subscribe and the bell notification. And if you have any question, please don't hesitate. Drop it in the comment section. We'll respond to your question. If need be, if it is a problem to solve, we'll solve it in the comment section so that you will understand what we're talking about. God bless you for watching our channel, Simplified Maths Class. See you in our next class. Cheers.